Okay, so we're going to do some moments questions now. And in this question, we're going to focus on the first common type of moment. So the first common type of moment that you will have to deal with is when we have a situation of a peg. So a peg means when you've got sort of, say, like a ladder here, and there's some particle, and what that does is it provides a reaction like that. Okay, so this is one of the common versions of a moments question. We've got a uniform rod. A uniform rod means that the weight will act in the middle and it will go straight down. So a uniform rod AB has mass of 40 kilograms, so 40 G. So this is one of the basic setups. It's on rough horizontal ground. So the ground does a couple of things. One, it provides normal reaction of itself. So whenever you've got like ground or a peg or a plane, these things give you a normal reaction. So there's a normal reaction there, and then there's a normal reaction here. Friction is going to be a consequence of this word here, but I'm going to get to that in just a second. The peg will be smooth for regular A-level, limiting equilibrium. Okay, so limiting equilibrium, we talked about in the last video, that means that the resultant force of the situation has to be 0. So the left has to be equal to the right, and the up has to be equal to the down. It also means that the clockwise must be equal to the anti-clockwise anywhere in the question. Okay, so this is the basic sort of situation. Notice we have just before I go any further, we've got a bit of a situation where the arrows are a sign that something isn't right as well here. So can you see I've got up, I've got up here, I've got down. So up and down, that could be balanced. But one of the issues with over here is this diagonally is made up, isn't it, of up and to the left. And I really want to stress the bit to the left. So if I just zoom out for a second, one question might be, well, it doesn't look like it's an equilibrium because it suggests that this whole thing should be moving to the left. Where's the right force? Well, the right force then is going to be that friction. Okay, so that's mu R1. So if I just sort of highlight all of these now, I could highlight the diagonal, or I could highlight it broken up. Can you see this is sort of the situation that we've got in front of us? And all of these forces are acting on the ladder or the beam itself. Okay, so we're considering the forces on this. So we're not looking at the ground itself. We're not looking at the peg itself. No. We're considering everything that's interacting with the ladder. So I'm going to zoom ahead now to a slightly neater version. This is one way that you could draw the diagram. And we're sort of ready now to start going through our different parts of moments. So I'm going to first of all talk to you about the clockwise, anti-clockwise condition of equilibrium. So we usually take moments at where if it's contact in the floor, we normally take moments there, because when you take moments, the forces where you take moments are 0 away. So in effect, you can ignore them. Okay, so we're going to do moments at A, and we're going to consider first of all which force we come into contact with. So it's this 40G here. It's 5 meters away. It's not currently perpendicular, but if I wanted to make it perpendicular, that 40G would be what? It would be 40G cos 15 we talked about in the previous video. If you're not sure about that, please watch the previous video. So that would be the clockwise moment, a distance and a force. So there should be 2 parts. So that's what's sort of making the ladder go down that way clockwise. So what's stopping it from hitting the floor then? Well, it's this peg up here. So if we carry on and get to 8 meters away, the force in this diagram is called N. And because they are already perpendicular, that's pretty much all I need to do. Okay, so that's the moments calculation. There are no other forces that create a moment going away from the ground. So 200g cos 15 divided by 8 is going to be equal to our normal, which is 240 newtons to two significant figures. Okay, because it's a peg, this is a nice question. When it's not a peg, you'll see that this will be a little bit more involved. So this part of the question is nice. Unfortunately, another part of the question is going to be a little bit more difficult. So one of the other conditions we talked about is we said that left has to equal right, up has to equal down. Now, if I get rid of all of this stuff on the diagram, just so you can see it a little bit better. Okay, one of the issues is not everything is already up or down. So that's vertical, great. That's to the right, great. That's down, great. This is a problem. It's diagonal at the moment. So what I want to do is I want to, similar to how we've done in previous sections, I want to split this into up and to the left. Okay. It's 15 degrees in here, and we're calling the hypotenuse n. So if it's 15 and n, this is the adjacent side. So this purple side here will be n cos 15. And this one here, which is opposite, will be n sine 15. Okay, now if I get rid of, well, that's just confusing. I've resolved it, so I can ignore that now. So if I just sort of zoom out again, you can see that the question is now useful to me. I've got some of these things here that are vertical. So R is a vertical, 40g is a vertical, n cos 15 is a vertical. So they all go into an equation. And then I've got mu R and n sine 15, and they go into their equation. Okay, so the green ones are going to go into that one there, and the vertical ones are going to go into that one there. And from there, the question should be fine. The skill really is in carefully identifying all of them and breaking them up in this case. So I'm going to sort of zoom ahead a little bit now, because I've done this one before the video timed out on the previous one. So I'm going to say then that R, which is the up force, n cos 15, which is another up force, equals the force down, 40g. So that's this one here. The left equals right is just this friction down here is equal to this leftness from the peg, which is this one here. The question wanted mu. So if you rearrange this one to mu equals n sine 15 over r, and you sub in your numbers, you can see how close we were before the previous video timed out, you will get 0.37. Okay, so in a nutshell, let's try and summarize then. This is the first of our common situations, which is a peg. A peg situation roughly looks something like this, and this is pretty much the way that we'll handle it. Consider everything acting on the rod itself. Work with left equals right and up equals down. Sometimes this will be easier or harder, depending on the question type. Work with clockwise equals anti-clockwise. These are your three main steps. Pegs, the moments first tends to be a little bit easier, and the up, down, left, right tends to be a bit harder. We're going to go on to the wall next, and on the wall, the left, right, up, down tends to be a little bit easier, and the moments tend to be a little bit harder.